morning. I really feel the pressure of the moment because, geez, you've set a hard task for me as an air conditioning manufacturer. How do we respond to what's going on? And luckily, that's what I've prepared. Let me see how I go with technology. Really, the very first step is that we've been working on changing our product hierarchy. In the good old days, we had a product. We've been recognising in the last few years that we need to develop a range of products. We need to be able to offer different customers different answers, different solutions for their projects. And so we've now got a standard unit, an eco unit with a little bit more control, a little bit more efficiency, and an eco ultra unit with, again, a little bit more control and a little bit more efficiency. So we've been building that. We've also, as well as expanding that, we've been making these technologies available across all of our ranges. So it's not just one product range, it's actually, we've got a common platform where we take the same technology and apply it in lots of different areas. So whether you're talking about variable capacity compressors or fans or smarter controls, they apply to all of our product groups. We've also been busy commercialising these products, so they're actually available. By commercialising them, it also helps us keep not only lead times but costs under control, something that's been mooted out this morning. And it was exciting for me to hear about so many of those existing buildings that are out there, because that's exactly what I hear in my office, is the number of jobs that we do that are replacement products. So for replacement projects. And what I'd like to do is take you through just how we respond when people say, well, what's the difference between your products? That's fantastic that you've got a high efficiency product. Almost prove it. So let me take you through a simple case study. What we actually did is about 4 or 5 years ago, we were doing a lot of custom products where we'd put higher efficiency fans, different higher efficiency compressors into products. And we were working on a job with Officeworks in Queensland, who they were starting to think about efficiency and how do I improve the efficiencies of my sites. And it pretty much boils down to, as noted up there, some digital compressors, some EC fans, electronic valves. Well, actually, there's actually not a lot new about those items, but what they are new, they're central plant. They're very common in central plant, but they're not really common in the package unit type marketplace. And I take that sort of analogy that we're bringing that central plant to almost to the common man, to that common sort of project. So we started by saying, okay, here's a building, let's do a heat load on a building. Well, actually, let's go back into our own data and start looking at, well, what's our standard unit? What's our premium unit? But actually, most people are asking us about replacing an old unit. Rummage through the filing cabinet. What did our product look like 10 years ago? And we ended up stepping back about 20 years, back to an R22 rooftop package unit. And so we just put all the data together. And we ran one common building through Camel heat load and through Beaver to look at energy usage over time. And so we started to look at the fans, the indoor fans, the outdoor fans, the compressors on heating, the compressors on cooling, and just looking across the year and saying, where's the energy used? And actually over time, where's the energy changed? And the fascinating part of this, when I study this, is that fans, indoor fans, are actually the number one item for saving of energy. It's the number, whereas it's been drummed into my head, geez, get your compressors right. It's actually not where all the energy is used, which I find quite fascinating, and that's in Queensland. That's in a site in Queensland, so obviously when we bring that to Auckland, that's a little bit different. But as we started going through these reviews, we were working with not only doing theoretical modelling, but we were going out to our customers and saying, can we monitor your equipment? And it's interesting, I saw a note up on the screen earlier mentioning Vicinity. We've been doing a bit of a case study with Vicinity ourselves, where on one of their shopping centres, we worked out that they were running their plant for 20 hours longer than the stores were open for. I reckon that's sort of like that low-hanging fruit. It's not all about the product. It's often about, as was said earlier, the life of the building and somebody's changed the time clock. Instead of changing that one night to late night shopping, we've got late night shopping every night. Some really simple things like that are the things that we've found. But what also happens if you think back 20 years ago? Economy cycle was actually really quite rare. We used a lot of electric heating. Filters, we like to call them rock stoppers around our office. Humidity was controlled, but quite often humidity was controlled by reheat. And so not necessarily the most efficient way. But what I'd like to do is take you through how, as this expanded, we started looking at, well, I've got to be able to tell people what's the difference in my product. And we went, well, actually, I've started on a shop. Well, actually, I've got lots of different customers. There are people who have data centres, there are people who have clubs and bars and offices. So we expanded our scope. And then we went, oh, geez, I've got to cover the whole of our business from Singapore to Christchurch. One's a little bit warmer than the other, I think. So we basically took the one building and we modelled it in 6 different locations, in 4 different applications, which all of those things change, not only temperatures, humidities, operating hours, and actually going, how do I tell someone this will be really good for you, this unit? Or what are the benefits to the product? So we kept working through that process. And we sort of got to a bit of a general rule that says it's actually not hard if you're taking an old unit and want to upgrade it to find about 50% in energy savings. It's actually not that hard. But let's look at an Auckland project where we did one of those studies was on an Auckland shopping centre, 2,600 odd square metres. What would happen if I had an old R22 unit? What happens if I replace it with a current unit? What happens if I replace it with our premium high efficiency product? And using rooftop package units. And so we looked at individual store analysis, looking at the energy. We also looked at lifetime cost savings, and we looked at CO2 emissions. So let's step through that. And so I look at Auckland, and this is a retail space, and just remembering that this is all about comparing our different models. It's not about a heat load on a space, because I must admit we made a few assumptions. We took a shopping centre and we went, we're just going to assume that it's a brand new, beautiful building, really well insulated. The builder actually cared when he put it all together. There's not a lot of infiltration. There's a nice airlock at the entrance. There's, a typical retail. I don't know if you've been into somewhere like Harvey Norman recently. The bright lights and the heat from the TVs are a little bit overwhelming. So you see here, there's actually not a lot of heating load on this analysis. But when you start looking at the difference between if you had an old unit, 10, 15, 20 years old, and a modern unit, it's nearly a third the actual electrical input. And this is all based on about 16 cents a kilowatt hour. We argued over what number to put in there because at home I pay over 30 and some of our larger commercial people pay a lot less than that. We took a middle of the road. But again, it shows the difference between a good product and a poor product or an older product. I shouldn't say poor product for our older product, should I? Sorry. But how does that, instead of a huge table of numbers, what does that look like? So a 34% saving in energy when I just update a new model. But more like a 60% saving when I actually go to our premium models. But it's not just about the product, you've actually got to get the rest of the system right. Controls is a huge part of controlling our new units. I know from experience that we've sold a lot of our premium products to people who have not used them in a premium way. They've not put the smart controls on them. They've not varied the fan speed. They've not varied the capacity of the compressors because they've just done it the good old way. They connected up the old thermostat, which might not have had those features. But when I start thinking about this is energy savings and costs, as it was talked about earlier about broader values, what other values can be attributed to a product and a change? What's the recycling culture of the supplier? How far did the product have to travel on the road to get here? Was it was it a few minutes down the road from Mangere, or was it from halfway around the world? There are lots of other things to consider. What's the longevity of the product? As we look at cost of ownership, this is another topic that we debate greatly with a lot of our customers, especially as refrigerants are being phased out and refrigerant costs are changing. Once upon a time, it was just top it up, mate, she'll be right. Whereas these days, it can be very expensive to have a large refrigerant leak. So that column about maintenance is really quite controversial. When we looked at this, we went, let's just pick a dollar value, dollars per kilowatt. What's approximate cost to change? What's the approximate cost between a standard controls and a premium controls, between a standard product and a premium product? And you'll see the differences there, that it's 10 or 15% to the project cost to go to a premium product. It starts to affect the maintenance, but can have a larger effect if maintenance is actually getting out of control. But one of the questions that we start to ask ourselves is, when is it actually appropriate to replace an air conditioner? Is it actually because it's getting a bit old and it's getting a bit rusty and it's starting to fail a bit too often? Or is it a little bit like our food at the supermarket, where the efficiency is a bit out of date, where you can start saving significantly on the actual installation costs? And I often get in philosophical debates with some of our, especially corporate customers, when I say things like that, but it's what's appropriate. We've had a few customers over the years who've had the philosophy, who knew some of this data, who had the philosophy of, if it breaks down, replace it. Don't spend one more cent on the product because of that energy saving for the future. And it's working, as Andrew introduced me, I've been around Temperzone for about 25 years now, and both in residential and commercial sales, and I've often been a little bit embarrassed that the residential market thinks more about energy efficiency than the commercial market does. And it's really nice to see the commercial market actually catching up and actually starting to do something about it. And I'm quite excited when I see our customers who do make those choices to actually replace a product with a higher efficiency product to actually get the benefits. And I haven't even spoke about the fact that the R22 refrigerant, that if you leave it there too long, will probably leak out into the atmosphere instead of being recovered and reclaimed. I know a few more, I am based in Sydney, so I know a few more of the Australian statistics off the top of my head, that I know in Australia that 500,000 high wall splits are replaced every year, and the reclaiming and recycling of refrigerant tells us that hardly any of that R22 is actually reclaimed. I know that in Brisbane, a local authority there pays a service mechanic to run around metal recycling yards to take refrigerant out of old units, because they just get dumped on the scrap heap and they get squashed by a forklift, and the gas gets let go. So even though as a trade we may well be doing the right thing, but there's broader people out there who actually start to have an influence on how our industry performs. When you start looking at payback periods, this again is it's a couple of years. If you're talking about, well, I'm going to replace my product, the difference in price compared to the savings on running costs, it's only 2.5 years. That's as long as you're going to do it anyway. It's actually a far harder argument if you went, well, I reckon I can get 3 more years out of this plant before I change it. That changes that argument greatly. It also changes dramatically if you're only just replacing the product and you're not making larger installation changes, because that'll reduce the cost and hence lengthening or shortening the payback period. And these days, at Temperzone, we find that a little bit of Australian-New Zealand rivalry, that in New Zealand, in our commercial product sales, it's about 80% of our products are our premium products. Whereas in the Australian marketplace, it's actually only about 40%. I would prefer to win the Bledisloe though. But I'll have, it's great to see your marketplace actually adopting higher efficiency products. And obviously that flows on to carbon dioxide emissions, and in the essence of time, all of the numbers are there, but there's plenty of our sales guys around if you want to grab those numbers. But there was an example earlier of when a property group does something. We often talk to property groups, and you start looking at some of those savings and replacing products. A lot of our, there's quite a few sites around here that might have 50 package units on one building, let alone on 50 different sites. And when you start adding up the numbers, geez, there's some big numbers in the savings, not only on energy but on carbon dioxide. What the effect that can be had when it's a broader community, we actually do something about it. When one customer does something about it, very hard to make a great influence. Even some simple things like economy cycle. I've seen old buildings where they just replace the old product, but they don't upgrade and put an economy cycle on it. And I just go, you can't be serious. It's amazing how that happens. But I think that often the decision making going from it, let me tell you, my favourite show is Undercover Boss, how you have this great philosophy up at head office, but geez, the shop looks disgusting. And I think that sometimes happens in our industry, where the concept of going for higher efficiency products starts, but we might let somebody a bit further down the supply chain make those product purchasing decisions, who may choose it on lead time, not on efficiency, may choose it on price, not efficiency, may choose it on their preferred supplier. Might just be a relationship, they understand the controls. Simple things like that. But as a product supplier with a really broad range of products, I thought I'd just take you through a few little slides that just show it's not just commercial sales. There's actually enormous things happening in the residential sector. And simple things like turning off your air conditioning at home in the room you're not using. It actually sounds really quite simple, but a few years ago, everything was on, mate. Now we're getting to the point where our simple controls can let you set different temperatures in different parts of the house to different time clock functions. And while that sounds quite simple, if you take that a step further and look at what does that mean, it actually means that for most of the time, you're not actually running the whole of the house. When you don't run the whole of the house, when you're using 60, 70% of the unit's capacity, not 100%, you've actually moved up this line to a more efficient place where the unit actually works. So not only are you not air conditioning a space you're not occupying, you're also using a product more efficiently. All of these same things apply commercially as well. The same principles, the same products are used commercially as well. And so, and I know this happens in the chiller marketplace, where a chiller may well be chosen because maybe choose a slightly larger chiller because it operates a little bit more efficiently. It's not really done residentially. It's not really done in a lot of other parts of the market, but there's opportunities to choose products to perform from an efficiency perspective instead of just what's the cheapest dollars per kilowatt. Same principle applies to chill water fan coils. We've done a lot of work recently, not only just putting higher efficiency fans, but making our coils be able to work with a broad range of temperatures so that we can help the chillers perform better. So it's almost not about our product saving energy, it's actually about somebody else's product saving energy. Chill water fan coils have developed where, in a similar way to zoning in a house, where we're actually putting multiple fans so that we can actually control how much air goes to an individual zone in a simple fashion, which obviously has energy saving when you're not overcooling one area, overheating one area, or putting too much air in. I copied a picture from before. Even in a simple old high wall split, which the reality is that the marketplace is the amount of energy used by high wall splits is something like 3 times the amount of energy used by commercial air conditioning, because there's hundreds of thousands of them sold every year in New Zealand. It's closer to 1 million in Australia. And even simple features where we've done a few school and type of projects where even just something simple like putting us, instead of the simple remote control which gets lost, we make a lot of money out of spare parts selling extra remote control. But if you put a more complex controller on it, you can lock the temperature range. Can you imagine a school, what temperature all the children set it on? It's always 28 degrees on heating and always 16 degrees on cooling. But you can lock all of those things. You can set it so that it turns off every hour. So you've got to go up and press the button again. Well, my kids would be pretty good at doing that, but at least you're stopping them turning it off, making it turn off after they've gone home, instead of them turning it on 5 minutes before school ends because they're getting a bit frustrated and leaving it on all night. Just really simple things that apply to all sorts of products that help us think about energy. And even this slide here is from our dear old government, from one of their papers looking at energy efficiency on high wall splits and how it's changed over the years. And a 50% improvement in efficiency levels of a simple old high wall split. And it's not uncommon for us to come across a large building, a shopping centre, where there might be 100 high wall splits just hidden in lunch rooms, car parks, first aid rooms, all sorts of little places, server rooms, as well as the main central plant. But again, it's just another area for energy. There's a few emerging technologies like hot water heat pumps. In the good old days, it was a boiler, whether it was gas or electric. But the actual energy cost to run hot water from a boiler is significantly more than a heat pump. And obviously that same saving flows through to carbon dioxide reductions as well. And because of some of the simple things about the technologies, because we're able to deliver real-time production of hot water instead of lots of storage, you can actually create reduced storage, which reduces capital costs, as well as those reductions in running costs. And that's across a wide range of products, literally from fast food to process heating and even process cooling, or heating homes. And this is probably one of the largest growing product groups that we have. Just adapting to people just recognising that there's new ways to do things. We've solved some of the problems of the past of hot water heat pumps. But let me finish by giving you a little bit of a vision for the future. We've coined the phrase humidity intelligence because we believe that our products need to do more than just think about the temperature. They need to think about occupancy, they need to think about maybe the humidity levels, because these things can actually dramatically affect the efficiency of the product. We need our products to be able to say, it's really dry today with very few occupants, therefore I'm going to change the way I operate so that I operate efficiently today. And a lot of those features are actually available in a central plant, but not in a little old package unit. Not in a package unit where there's hundreds and thousands of them over the roofs of our countries. And a good example is, whether it be in Queensland, this happens a lot, but it also happens a lot around here where you get a good old sun shower. It was beautiful in the morning, rain for half an hour in the middle of the day, and the temperature just changes, the humidity levels just change. And if our products just do the same old thing, you don't achieve the same comfort. And I don't know about you, but working in the air conditioning industry, if I'm ever at a dinner party, somebody always says to me, it's always too hot at my office, it's always too cold in my office. I feel that what we do is spend a lot of energy making people uncomfortable. And I think we've got to change that to be able to take in more inputs so that we can actually think about things more. Let me finish with one little story which I think describes how do I take those inputs. I saw a great cartoon the other day for a Nest thermostat, which was shown up on the board, I think by Ross earlier, that a colleague turns around in his office and he says, "Oh, my Nest smoke detectors just offered me short-term accommodation and a rental car. I think my smoke detector's gone off." Sometimes marketers work out how to take data and sell you stuff. I'd like to think that we take that data and help our equipment run more efficiently and in a smarter way. We've got a lot of new products coming out. We're continually bringing out new things. Part of the process I briefly showed through in that case study is where we're building modelling tools to help some of our smaller customers, where if you can imagine being a landlord of let's take it as a fish and chip shop out in the suburbs, when somebody turns up and says, instead of costing you a few $100s to fix up your unit, it's going to cost you $40,000 to replace it. How do I at least help you understand the energy changes that are going on? How do we help with that data instead of just, it's very easy to work out a quote. It's a lot harder to actually work out a vision for the future and how that's going to operate. I have tried to flick through as fast as I can because I know we're catching up, Andrew. I haven't really been watching my watch, but I'd like to think that at Temperzone we understand what's going on out there in the marketplace, and we're trying to change our products and evolve as a business so that we can help support our customers through the change. So thank you for your time. Hopefully I've added some value to the day. Thank you.